This is the implementation of a Spring Boot microservices. In this service, sorry, in this project, here is an index. We'll be going to cover project structure, architecture, and the recap workflow, whatever we have done when we learned this project, when we did this project, we'll be going to cover this at the bottom. Then we have the Zipkin server, config server, service registry, that is the Eureka server, API gateway to route all the requests, API requests to the business services. Then we have the business services and microservices communication demonstration in the README file. So we have there the department service and employee service nodes. Then we have some little bit documentation folder and microservices nodes. There I haven't added anything, so I'll be not going to cover anything there. Then we have the web client config reusability. So I'll be going to show you how we can use the web client for multiple services. Then here it comes, project structure. In the project structure, we have the config server, service registry, that is the Eureka server. Then we have the API gateway, department service, employee service, that is the business services, and then Docker Compose. In the Docker, we are going to run the Zipkin by using Docker. So we'll be not going to run the Zipkin using local machine. It is not recommended way. So yeah. So talking about the architecture of this project, or you can say that the Spring microservices, we have the config server. It stores the centralized config. We can import the configs of business services if we have stored inside the config server. Then we have the API gateway to route all the APIs to the respective microservices, or you can say the business services. Then we have the service registry to register and discover the services or communicate with each other. It is used for that. Then we have the business services. In that we have a department service and the employee service. Then we have the Zipkin to track all the logs between all of these services. So we'll be going to run it on the Docker as we have discussed earlier. In the business service and in the department service, there is an API which will be going to call, which it will be going to call the employee service API. So this is a demonstration of a intercommunication microservices. Okay, microservices intercommunication by using the webflux. This is a reactive way. And the API gateway which we'll be going to use here, it is not a reactive. It is just a gateway. Okay, it is not a webflux or API webflux. Okay, there then here it is the little bit the functions of their respective services. Let's start from the service registry. That is the Eureka server. It keeps track of all running microservices instances. Repeat, I will be going to repeat again. Okay, keeps track of all running microservice instances. Keeps track of all running microservices. Repeat again. Keeps track of all running microservices. Then helps in load balancing, scaling, and auto discovery of services. This is very important because when we'll be going to deploy this all of these services on the Kubernetes, we don't even require this Eureka server, because load balancing, scaling, and auto discovery of services, it will be auto configured in Kubernetes. So we don't even require this server register, sorry, service registry. Okay, so that's why you should take a note that service registry here you require. It's because of load balancing, scaling, and auto discovery if you don't want to put your microservice or deploy your microservice on Kubernetes. Okay. Okay. After that, we have the config server. Provides a central place to store shared configs for all microservices. As we have discussed earlier here, it stores, so I have a API gateway service, department service, and employee service. The properties belongs to the services I'll be going to store on the config server, so that we can I mean it will be helpful for to manage all of these services properties at one place. So that's why we want to store the all the properties inside the config server. There are two ways to store in that, the native way and by using the GitHub also. So we'll be going to discuss about that later. For the time being, will be on config server, and it is used to store the it is a central place. Okay, note that it is a central place to store the shared configs for all microservices. shared configs for all microservices, allows updating the configs without rebuilding every service, allows updating the configs, right? You don't even need to rebuild the service image. You don't even need that. It's because of it you have to just build only one service again to deploy on the Docker or Kubernetes. You have to build only config servers because you are changing only config server, and all the other properties, or I mean all the other services is going to fetch that configs dynamically. Okay, there you are not changing anything. Then we have the API gateway, single entry point for all the client requests. Okay, single API entry point for all client requests. API gateway, what it does, single entry point for all client requests. Note that here it is a client requests. Okay, and which type of request client do? HTTP request like post, put, delete, update. Sorry, by mistake I gone there. So it is the post, delete. Then we also have the get and put and many more. So it is a single entry point for all client requests. Single entry point for all client requests. Then we have it handles routing, filtering, authentication. We can do a cross-cutting concern here. We can solve the cross-cutting like routing, filtering, authentication. This is a very important thing which all the companies do, and then rate limiting. So I don't know what does it mean, rate limiting. So but basically we do a routing, authentication and filtering. Okay, routing, filtering, authentication, routing, filtering, authentication, routing, filtering, authentication, routing, filtering, authentication. Then we have the Zipkin. So it is a distributed tracing. Okay, it is a distributed tracing. You just need a Zipkin to trace all the logs, and distributed tracing to track all the services, what's going on, which API has called from which service, and you can all of these details you can see by using the Zipkin. There you have a dashboard which will be available on localhost 9411 if you have given the port number 9411. Then going down, business services. Okay, first of all, we can check it also provides a dashboard to analyze latency, errors, and cross service logs. To analyze the latency, errors, and cross service logs. 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 Then we have the business service. In the business service, we have the employee service and department service. By using these two services, we are going to demonstrate how department service will going to call the employee service. That is the inter-microservice communication. So let's read these following two points. Each service contains its own domain logic and database if needed. Okay, each service contains its own domain logic and database. Obviously, there are it's a simple. Okay, business services are separate. It does a service. It also include its own database. So they focus purely on business functionalities. Okay, so you can say that other than these services, whatever the services remaining, you can say it as a business service if you don't know anything about that. Okay, there are some few other services as well. That is the uh, okay, I don't know when service gets down. There is a circuit breaker. Okay, there is one more service, that is circuit breaker, which I haven't added here. So I have just covered this much. So I'll be going to cover it after some time. Okay, let it go. So we have now, let's start from Zipkin server. Okay, where we are right now, we have just covered the project structure. We have covered the project architecture. And now we are on the Zipkin server. In the Zipkin server, as I mentioned, we are going to run it by using the Docker. So the command for that, it is the docker run minus d, that is detached, minus p 9411 to 9411. Okay, 9411, the first 9411 is the uh, it is the local host. Actually, it is your local machine port number, and the second port number is of the containers port number. So I'm going to revise, actually read it again. So here docker run minus d minus p 9411 to the 9411, open zipkin slash zipkin, open zipkin slash zipkin. Then after running this command on the Docker, you can access the Zipkin UI at localhost 9411. Okay, here there is a one note. Okay, so we'll be going to cover it after some time, but for the time, uh, here when you add the zip key in any service, there you have to mention the URL as like this. You don't have to mention spring.zipkin.base URL localhost and 9411. So this has deprecated, it will not going to work on this. So you have to mention management.zipkin.tracing, management.zipkin.tracing.endpoint, management.zipkin.tracing.endpoint is equals to http localhost http slash slash zipkin host, it may be localhost, then to the 9411, here it comes, slash API slash v2 slash spans. Okay, I'll be going to read it again. Management.zipkin.tracing.endpoint is equals to http colon slash slash zipkin host colon 9411 slash API slash v2 slash spans. API slash v2 slash spans. It is very, very important to add, otherwise it would give you an error. Let's start from now. Config server. So the new section is config server. For a config server, you don't just need a Spring Cloud config server, Spring Cloud config server, Spring Cloud config server, Spring Cloud config server. Then you do require annotation at the rate enable config server, at the rate enable config server. No other dependencies and annotation required for this then. So then properties. The properties for config server is required for you how to add spring.profiles.active is equals to native. Spring.profiles.active is equals to native, as we are adding the all the properties by using in the local machine. So that's why you do have to add this property, that is spring.profiles.active is equals to native. Otherwise you have to give the git repository or something other properties, I don't know how to give, but you have to give. So there are two ways, just we are using the all the properties, or we are using importing all the properties in from the local host or local machine. That's why we are using the native profile. Spring.profiles.active is equals to native. Then we have the server.port number is equals to 8088. Then how to add centralized config, so that this is very, very important point. So if you want to add the properties of our services, you have to create a one folder in the resources, that is a resources slash config, and in the config folder you can add services properties. So for that you have to give the name of service itself. Okay, if you give another name, it will not going to work, because when you try to import the properties of API gateway from the API gateway, then it will find the its name and then dot properties or YML from the config server. Okay, if it doesn't find, it will give, it will not going to import. So for that you have to give the service name itself, like API gateway employee service department service dot properties, and you can add there the properties, except some important properties like application name also you can skip there. Then we have the each microservices loads only its matching file, and here properties of config slash dash dash service are shown in their respective component section. Okay, require the same service name as the spring.application.name. Okay, as I have discussed. Then we have the service registry, that is the Eureka server. It is one of the important service in the microservices if you are using just for local machine. Okay, if you don't want to use the Kubernetes, then here you require Spring Cloud starter Netflix Eureka server, 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 Netflix Eureka server, Netflix Eureka server, Netflix Eureka server, Netflix Eureka server. No other dependency required for this, as it is a server. Then annotation at the rate enable Eureka server, at the rate enable Eureka server. Then the properties Eureka dot, there are four properties which we do require for to configure the Eureka server, and note that we have to register it as a server. So here config application, we have to give the first spring.application.name, then server.port is equals to 8761. So we are going to run the service registry on the port number 8761. Then we have the four important properties which we have to give. First, eureka.instance.hostname. Okay, this is currently my local host. It may be other IP address as well. Okay, so eureka.instance.hostname, it is currently localhost. You can add the other IP address as well. Eureka.hostname. Okay, eureka.instance.hostname, eureka.instance.hostname. Then we have the three important properties: eureka.client, 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 register with eureka, fetch registry, service URL dot default zone. I'm going to repeat again: eureka.client dot service registry, register with eureka. Sorry. Okay, I'm going to repeat again: eureka.client, register with eureka, then fetch registry, service URL dot default zone. In the service URL dot default zone, we'll be going to give http colon slash slash import the eureka.instance.hostname property colon import the server.port slash eureka slash. I'll be going to repeat again: eureka.client.service URL.default zone is equals to http colon slash slash import eureka.instance.hostname colon import server.port slash eureka slash. So you'll be going to import eureka.instance.hostname and server.port from current properties. Okay, whatever you have given here, this local.instance name and port number. So I'll be going to repeat again. We have to give three main properties: eureka.client, then we have the register with eureka, fetch registry, then server service URL dot default zone. So coming back onto the API gateway, this is a non-reactive as I had discussed. We do require two important dependencies, but if for the API gateway, just API gateway, we want only one, that is the Spring Cloud Starter Gateway. Okay, both the and then we also require the Eureka Discovery Client as well. Spring Cloud Starter, Netflix Eureka Client. It is a Netflix Eureka client. In the server, it was a Netflix Eureka server. Okay, both the API gateway and service registry main dependencies start from the Spring Cloud Starter. Spring Cloud Starter. Okay, I'll be going to repeat again. In the API gateway, we do require Spring Cloud Starter Gateway and the Netflix Eureka client. Spring Cloud Starter Gateway and the Spring Cloud Starter Netflix Eureka client. And you can add other required dependencies for the project like Spring Cloud Actuator, Config Client, and Zipkin. Okay, so this also requires for this project. The annotation which we'll be going to use is enable discovery client, as we have to register this, or register this service in the Eureka server. Now, how we can route all the public client requests? Okay, so for that, first of all, we have to add some Eureka client, Spring config, and Zipkin properties in the API gateway properties. Here, the properties which we are going to add in the API gateway are, first of all, server port number 8060. You can add anything here. For Eureka client, we have the eureka.client.service URL.default zone is equals to http colon slash slash localhost colon 8761 slash eureka. Then we have the Spring config. Spring.config.import is equals to, it is optional colon, okay, optional colon config server colon http colon slash slash localhost colon 8088. Okay, here I have added the optional, which means it is optional. If it can wait for to import as well. Okay, then we have a Zipkin properties. To add a Zipkin in the current service, we do require two properties. First, management.zipkin.tracing endpoint. Okay, management.zipkin.tracing.endpoint. Okay, management.zipkin.tracing.endpoint is equals to http colon slash slash localhost colon 9411 colon slash API slash v2 slash spans. Okay, this endpoint we do require for here. as I have discussed. Without it, it will not going to work. Then we have a management.tracing.sampling probability. Okay, everybody is dot management.tracing.sampling.probability. Management.tracing.sampling.probability. Management.tracing.sampling.probability is equal to 1.0. It means it will be going to add all the details to the zipkin. Okay, now zipkin can track all the details including the logs and latency, everything. Then the real part of the API gateway, that is the APIs for exposing. Okay, start from here. So in the API properties, we have to add one more section for department service. We'll be going to add these properties. How we'll be going to, you'll be going to route these APIs. You have to add spring.cloud.gateway.routes. Just give me a second. Okay. For department service, first of all, you can open your YouTube and check it out where I'm right now. So here I'm currently I'm routing all the request API request of for the department service. Okay. How? Take a look. Spring, okay, for the department service, spring.cloud.gateway. Okay, here it is common for everyone for routing all. Okay, this much of what? No, spring.cloud.gateway routes. This is an array. Okay, for first microservices you can add one. If it is a YML, you can add, instead adding the array here like this, you can add dash. Okay, this is a list. You can have to give the list here, dash dot id dash dot uri dash dot predicates, like this. Okay, without it. So we have here spring.cloud.gateway.get gateway.routes, spring.cloud.gateway.routes of one. Okay, array of one, dot id is equals to department dash service. So you have to give the department name which you have registered with the Eureka, because ultimately the API gateway will going to route this request via server registry. It will be going to give that request to the service registry, and service registry will going to queue that request or send or hit that API request to the particular respective service. Okay, understood? Let's go ahead. Then we have the Spring Cloud Gateway dot routes of one dot URI. Okay, I'll be not going to repeat it again. So you have to take a note. Spring.cloud.gateway.routes. It will be going to start from this. Okay. So here we need to add ID, then URI. URI. In the URI, you have to give LB colon slash slash department dash service. Okay, you have to pass through the load balancer. That's why you have added the LB colon and your department service slash slash. Okay, LB colon slash slash department service in the URI. So we have to give the ID, then URI, then predicates of zero. Okay, this predicates is the URI actual APIs which you have to forward to this service, Okay, so predicates of zero, currently I want to give only one, then is equals to, okay, I think I should have to repeat all the property. Spring.cloud.gateway.routes of one dot predicates of zero is equals to path is equals to slash department slash star star, which means route all the APIs to the department service whenever I'll be going to get of that APIs. So then here you have to take a note. The predicates and the routes start from zero index. I have given you the department service first. That's why it has started from one. Okay. You can give it. You can start. You have to start the routes from zero index. Then we have the employee service. Same you have to do. Spring.cloud.gateway.routes of zero. Then we have to give the ID as the employee service. URI is equals to load by LB colon slash slash employee service, then predicates of zero is equals to path is equals to slash employee slash star star. It exposes the APIs. Gateway is the first entry point and it propagates the zipkin trace IDs. Okay, so what is the flow of this API gateway is, first API gateway get the request of for the particular respective API, then it will call the Eureka, then Eureka solves the ID and URI. which we have given here in the API gateway and forward the request to the particular service. That's it. I think it's enough. We have discussed a lot of things about API gateway. Now it's time for business services and microservice communication. Let's do that. Here are common things required to run the business services. Okay, instead I'm going to repeat in the employee service and department service. I have take out some common properties which we have used in that particular services. First, Eureka Discovery Client. Okay, you have to take a note down. We have to add a dependency Eureka Discovery Client, Config Client, Zipkin. Eureka Discovery Client, Config Client, and Zipkin. Then other dependencies as well. We require Spring Web to create the servlet dispatcher, obviously, and REST controller and many more. Right? For dispatcher servlets, we have to add Spring Web for APIs, then a Lombok and Spring Boot actuator. So the main dependencies which we have required for the Spring microservices is that the Spring Discovery Client, sorry, Eureka Discovery Client, config server, sorry, config client, and Zipkin. Eureka Discovery Client, config client, and Zipkin. Then we have the common required annotation used. That is, we have to register. If we want to register the service, we have to give the Eureka, sorry, enable discovery client. Register with the Eureka, okay, or server registry. Enable discovery client. We have to give this annotation on the top of application, okay, where our applications or service starts from there. So then we have the common properties which we have used, like for the Eureka client. Okay, now we were at the Eureka client. Okay, first of all, we do need, for each business service, we have to add these properties. Which one? For Eureka client, we have to add two properties. Then we do need a Spring config so that we can import the config properties. Then we do need a Zipkin properties. Okay, they are also two. So let's revise. So for Eureka client, we have to give eureka.instance.hostname there, otherwise it will be going to throw an error. I don't know why it has given me that time. Just add it. Okay, I haven't gone depth inside that. So you have to add for each business service. If you want to register with the Eureka, you have to add the eureka.instance.host name is equals to localhost, or maybe whatever the IP address where you have your server is running right now. So then we have the eureka.client.service url.default zone. Here you have to give the http colon slash slash localhost colon 8761 slash eureka. Then we have for the importing the Spring config, we do have to import spring.config.import is equals to, first of all it is optional, then colon, then the URL name config server, then colon the actual URL http colon slash slash localhost port number 8088. Then we do need to add two properties of a Zipkin. It's very important to add here for each business services. That is the management.zipkin.tracing.endpoint is equals to http colon slash slash localhost colon 9411 slash API slash v2 slash spans API slash v2 slash spans API slash v2 slash spans. Then we have management.tracing.sampling.probability is equals to 1.0 so that it can track all the details. Management.tracing.sampling.probability. First it was the management.zipkin.tracing endpoint, and now it is management.tracing, not Zipkin. Okay, first it was the management.zipkin.tracing.endpoint. Here it is management.tracing, okay, not Zipkin. Management.tracing.sampling.probability is equals to 1.0. Management.tracing.sampling.probability is equals to 1.0. Then in the department service, we have to here, I'll be going to demonstrate how we have called the employee service API by from the department service. Here we are going to calling the employee service using the web client, that is the React way, or you can say that web flux. For that, you do need a web flux dependency. Again, it is start from Spring Boot Starter web flux. Okay, I have noticed one thing. Actually, it is not. It was in the API gateway. Okay, in the API gateway, here when you import the API gateway from the Spring Initializer, it may not give you this dependency. Okay, it may give you either reactive or another. So you have to customize it. this dependency, you have to add only gateway here. Okay, there is a something another part when you import by default, so you have to remove that, otherwise it will not going to work. Okay, then going down where we were, okay, we were at department service. So now the main dependencies for communicating with the microservices is web flux. You have to add the Spring Boot starter web flux. Spring Boot starter web flux. Spring Boot starter web flux. Okay, remaining properties. Spring.application.name is equals to department service and server.port number 8081. That is not an important thing. So annotations which we have used, I'll be going to cover that, but for the time being, I'll be going to revise it. We will be going to use HTTP exchange on the top of the interface, and get exchange and post exchange like this we can use on the top of method declaration of that employee service client. Okay, go down. The project architecture will look like this: controller model repository, as we have for each microservices. That is not important thing, but for communicating with the employee client, we do need client folder and config package. You can say the client package and config package. In the client, there are only interfaces. Okay, just like we have the employee client interface. Okay, that is a client interface. Okay, again, I'm going to repeat again, we do need two packages, that is a client and then config. In the client, there are only interfaces, which includes only declaration methods, where we want to call that methods of that particular client. Okay, just like here, it includes the employee client interface, and in that employee client, the the API, that is the method which we are going to call of employee, uh, it contains only declaration. Okay, that's it. So let's go down. Then we have the config. In the config package, we have the web client config. So we are going to build actual the web client. Okay. Here, if you try to import the bean of employee client, it will not go. Spring will not going to give you that bean. So for creating that bean, we have to create the web client config. So in that web client config, you can configure the all the bins of whichever you have added in the client. It may be employee client, and if it other service you want to which you want to call, you can add you can create that bin of that particular client as well. So let's call the API of find by department of, okay, this is the find by department. This is the method which we are going to call of the call from the department service of the employee service. Okay, so employee to client, that is the client interface, as we have discussed, which is inside the client package. We have to tell it is a HTTP HTTP exchange. Okay, tell the Spring automatically create a dynamic proxy for the interface. It is very important. Dynamics proxy is nothing but the bean. Okay, it will be create a bean dynamically, which means at the running time. Okay, when you want to call that service, it will Spring will create that bean by using that configuration. Okay, we are telling dynamic create a dynamic proxy. That's it. Dynamic, it is a dynamic proxy. Okay, it has otherwise you know that Spring creates a beans before at the start of the application, but this will create a dynamic so that it will save a lot of resources as well. Okay, so you have to mention that interface as at the rate at HTTP exchange. Then you have to give the get exchange, post exchange. We have a lot of at the rate annotations, get exchange, post exchange, and many more. You have to add it as the top of the method. So also note that there is one thing in the get exchange, in the curly braces, you have to give the full URL. Okay, full URL, not just department slash department ID. No, you have to give full URL, just like I have added here the employee. Okay, of that request mapping in from the controller. So I have given the full URL. Okay, fine. After creating the employee client, that is the interface, we want to create a bean. Okay, so that it will create a dynamic proxy of that interface. For that, you have to create a web client config. You have to annotate with add that and configuration, and if you for importing or injecting the bin, you can add lombok property or lombok annotation, that is the required constructor, so it will inject. So here for web client, we have to add the private final load balanced exchanged. Okay, I will be going to repeat again. We have to inject a bin. Okay, it is a by default. Spring will give you by default bin. So you do need this load balancer a bin for balancing the load. You have to give with at the time of web client build. Okay, so what is that? Private final load balanced exchange filter function, load balanced exchange filter function. Okay, you have to import that bean in filter function. Then create a bean of employee web client which will going to return a web client. Okay, create a bean of a employee web client which will be going to return a web client. So how you will be going to return it? Return web client dot builder dot base URL. Here you have to give the base URL of http colon slash slash employee service slash sorry dash service. So service name you have to give this URL or service name registered in Eureka. Okay, whatever the service name registered with the Eureka, you have to give that here. Then we have the filter function, that is the dot filter. Then give the filter function whatever we have above import or injected the bin, and that is the load balanced exchange filter function. So this filter function we have to give in the dot filter, and then we have to build, and it will automatically return the web client. So how I'll be going to repeat again what we have provided: web client dot builder dot base URL dot filter dot build. That's it. So dot filter resolve the service name through the Eureka instead of DNS. Okay, why we have given the load balanced exchange filter to the filter to solve the service name through the Eureka instead of DNS. So that is very important. Then again, we do need one more bin. Okay, employee client. So this was the employee web client. Now we have to create actual interface bin. Okay, so we have to create employee client bean which will return the employee client itself. Okay, employee client itself. So this is a dynamic proxy. So for that we do need a web client adapter. Adapter is equals to web client adapter dot create. Here we have to call the employee web client method. Then in the HTTP service proxy factory, HTTP service proxy factory is equals to proxy factory dot builder dot exchange adapter give adapter dot build. That's it. And then we have to return proxy factory dot create client employee client dot class. Give it. So I have revised. I'll be going to revise this bin again. We have to create the actual employee client, which will return the employee client bean. This is the dynamic proxy. In that, we have to create the web client adapter object adapter is equals to okay, web client adapter that is equals to web client adapter dot create. Then call the method employee web client. Here we are giving the web client, okay, of employee client. Okay, here you can create multiple clients as well, so you can use the web client for multiple roles as well. Just you don't have to give the base URL, you can customize or re-give the base URL in this method as well. Okay, here because of I had only one service to call, so that's why I have given directly base URL in the web client bin. Okay, otherwise you don't even need to give their base URL. You have to again give how to give the base URL for the web client when you trying to create a bean for the your web uh, for your interface. Okay, like this. So again, web client adapter is equals to web adapter dot create. You have to call the you have to give the web client. Then HTTP service proxy factory is equals to proxy factory dot builder. Then this is my exchange adapter. Here is my adapter, and then build. So then we have to create a dynamics proxy using HTTP proxy factory. So whatever the object we have created, proxy factory dot create client, and we have to give the employee client dot class. What is this employee client dot class? It is an interface which we are giving to the HTTP service proxy factory. Why? Because we want the client, that is a dynamic proxy. We are telling HTTP service proxy factory that please create my bean, and that should be dynamic. Okay, create my bean of that interface. So for that, creating a dynamic proxy, we do need a HTTP proxy factory service proxy factory. Okay, that's it. So HTTP service proxy factory turns the interface employee client into runtime HTTP client. Okay, the final result HTTP client looks like normal Java interface, but under the hood it uses the web client. Okay, web client plus Eureka plus load balancing plus dynamic proxy. Okay, this much of things you do require to communicate with other microservices API. Okay, fine. After that, everything else fine. So you have to import the bean of employee client in the controller for calling the API of that employee service. Then how will be going to call it? Like this: employee client dot find by department and give the whatever it takes. So you have to just call the method declaration of that particular interface, and you will be getting the result. That's it. So, or the foreground of all the background things, the Spring will handle and breakfast will handle. So here also in the controller, I forget that why we have added logger.info. It's because we want to track the zipkin. So this we can see these logs in the zipkin as well. Okay. So yeah, that's it. Now you can bin the employee clients on config. Okay, whatever it is. So how you can create the logger? That is, you have to create private static. Or by mistakenly I have added the static. You should not. You does not require the static here. Private final logger. Okay, logger is equals to logger factory dot get logger, and you have to give the current class dot class. Okay, department controller dot class as class. Then in the employee service you don't even require anything here. So here, as it is a non-reactive, we haven't added the mono or flux or stream to stream the API request or reactive way. So we don't even need to add anything in the employee service for communicating. So yeah, it returns the list as we have discussed. It does not return the mono or flux. That is the blocking or synchronous, and it does not stream data and not returns web flux and mono as I discussed. So if you want to make a reactive way to communicate, you have to add just a flux. You have to return the flux of employee or mono of list of employee there. Okay. So now it's time to recap the workflow. We are at the end of this microservices revisions. I know it has been a lot of time that we are recording the video, and I think I should have to wrap up all of this. So we have started. First, start the Eureka server service registry, then start the config server. First, start the Eureka server, then config server, then zipkin, then run employee service and department service, then both import config from the config server, then both register to the Eureka, then both send traces to zipkin, then run API gateway, then register to Eureka, then routes traffic using. Okay, then in the API gateway we have configured the properties we want to traffic, routes the traffic from the load balancer. That's why we have given in the predicates we have given their path as, sorry, in the URI we have given the lb colon slash slash. Okay, then there's one important thing which I have mentioned. I forget. I think the Eureka UI, we will be going to available Eureka UI and Zipkin UI. In the Eureka UI, you can check all the services whichever we have registered and a lot of things there. Okay. The Here it is available on the port number 8761, and Zipkin UI is available on the port number 89411 slash Zipkin slash. That's it. The references and whatever it is. So yeah, that's it. This was the video. Thank you.